introduction to me. Is it okay? Okay, no problem. Hmm? Okay, okay. Something happened. This is normal. Okay. 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 Okay, for the preparation, I start talking. Okay. Okay. Anyway, thank you for kindly introduce me, and I'm very honored to have a lecture here, because as Joyce Sen said, this is the third time to come here. Okay. And my first visit was 10 years before, and last visit was 2 years before, and all time I came here, I'm so impressed. A very good environment of this campus, and now I'm staying at guest house, quite nice to stay. Okay, and I completely enjoy to stay here, and I also have a much pleasure to have so dense lectures, maybe for 5 days, and my part maybe 9 hours. Okay, 9 hours. Yes, and mostly this lecture was will be conducted for 3 guys, including me, and my part mostly for some lecture type. I will provide some lectures regarding the Japanese experiences, not only on the ITS, but for the transport planning and management. And I will talk about the update information, what we did and we do and we will do, okay, relating to the ICT or IoT applications in transport planning and management. And now, no slide, okay. Okay. Now I'm working on the Tokyo Metropolitan University, as Joy introduced. This is a public-owned university. This is the Japanese largest public university, and our ranking, university ranking, in the 9th or 10th in Japan. not so low, but not so high, frankly speaking. And before working at TMU, I was in the University of Tokyo, and the story why I'm here today is same. And at that time, I belonged to civil engineering department. Okay, and I originally from civil engineering. I was student in the late 1980s or the beginning of 1990s. Okay, at that time there is no ICT, okay, no IoT, and what I learned is very conventional transport planning issues and some technologies to make transport infrastructure, okay, rather than management. Okay, but during my academic era, starting from the middle of 1990s and this century, the transport world completely changed. And within next 10 years, we may have biggest changes. Okay, the same change happened 100 years before in the world, when we have locomotive trains, or we have motor cars, or we have airplanes. Okay, and those devices are almost completed for its development, except automation. Okay, But recently, for civil engineer like me or some other persons, we should know much about IoT or ICT to deal with many things, okay, including the transport, planning, and management. And but my work in this field a little bit conventional because I'm just start to learn what is MaaS. I will talk later. Mobility as a service. This become very buzzword in the world. Okay, and this rising of MaaS might be the next biggest changes of the transport world in the next decade. Okay, and now I'm currently be the professor in the tourism science department. Yes, of course, tourism is the one of the application the transport planning should manage. Okay. And actually, even though I'm now in the department of tourism science, the most of my work is for the transport planning. Okay, so please be safe. Okay. Okay. Yes, and this is 5-day lectures. Okay, and today I have 3 lecture slots, and I will talk that Japan and Tokyo's experience in this field, what we did, and what we do now. Okay, and TDM might be provided by the Arkopal. Okay, yes, and day 2 tomorrow. Time is so limited because I only have 1 hour. Because I will talk about the data collection technologies, okay, for transport planning and management. And maybe it's better to talk a little bit about this part within today to save the time. Okay. And Wednesday, I will talk about traffic safety issues and load pricing issues at the same time using 90 minutes. Okay. And day 4, okay, day 4, I have again have a 3 lecture slot. Okay, and I will summarize my talk, speaking on some policy and measures, its history and future. Okay, and issues and benefit of the ITS or IoT or ICT in the transport planning and management field. Okay. This is all I will talk here. Okay. And unfortunately, the last day you have maybe examination. Okay. And we may have some concluding sessions. Okay. Okay. So I will start from our experience, okay, in the transport planning and management. Okay. Before understanding ICT, IoT, ITS, you should understand the conventional transport planning issues, okay, and management. Okay. And actually, maybe have you ever been to Japan or Tokyo? No? Okay, so I should speak carefully, including the information of Japan and Tokyo. Okay. Okay. And before that, I will explain a little bit my motivation in the study field. Okay. Actually, transport is not goal. Okay. Mostly, transport is just mean or measures to have a daily life. Okay. So, for example, today you have lecture here, okay, and you may use somewhat transport to come here, even though you just walk. We need a load, okay, load. But the importance of load is not itself, but so you should come to this lecture. So you need a load. Okay. Finally, our goal is to make our urban form sustainable using the transport, providing a better transport system. Okay. And sustainabilities have some various aspects, but mostly for the economy aspect or environmental aspect. Okay. We need to control our urban areas sustainable, okay, both by the economically and environmentally. Okay. And 全部出しようかもね。Okay. And measures to make our urban form sustainable. So at least we need 4 different aspects: demographic planning, and economical planning, and environmental planning, as well land use planning. Okay. Mixing these 4 planning, so we can make our urban form sustainable. Okay. And to realize this chain of measures, we need various kinds of technological infrastructures, not only transport, but for the water or medical, food, everything. Okay. And so if we deal with the technology, so not only the technological and scientific aspect, but we need some history or geography, climate, thought, and culture understanding of those fields. So transport study or social, the study field of technologies, which is socially important, requires not only the knowledge on the technology, but on the some everything, okay, including the culture, thought, history. Okay. And regarding the transport system, okay, I will mention later, there are 3 important elements in the system: way, terminal, and vehicle. Okay. And I'm civil, so my role is to construct a way mostly. And architecture have some role to develop the terminal, like a station or airport. Okay. And vehicle, so this is responsible for machinery or electronic persons should have some responsibility in developing vehicle. Okay. So to sustain the transport system economically or safe, so we need to collaborate these 3 major players. Okay. And ITS is a kind of some communication field participated by the civil, electronic, or machinery. Okay. Okay. And 10 years before, Joy kindly explained the COE project by the University of Tokyo. At that time, we had several researchers on the urban transport plannings, and we collaborate with the top professors in each countries in the Eastern or Southeast Asian regions. We published 1 book, okay, entitled "The Sustainable Urban Transport in an Asian Context." Okay. Maybe I'm not sure you can find this in the Amazon or not. I'm not sure, but maybe try to read if you find this. And the point is, of course, modern transport system has been developed mostly in the Western countries. Okay, and we just import those ideas, okay, and elements. But to fit those systems to our environment, we need to modify or we need to change our mind, because, for example, we have so severe natural environment, including natural disaster, okay, compared with the Western countries. Okay. And this is my understanding. Western countries, the public very strong to control everything. But our case, private, sometimes have a very big power to settle down the situations. So this is frequently observed in the transport market. Many private sectors operate with less control by the government. But this sometimes makes the situation very better. Okay. Or Asia maybe we have more than half of the population in the world, and those people are mostly concentrated on the urban center. Okay. So we need to develop densely in the urban centers compared with the European cities or US cities or Oceanian cities. Okay. And our transport infrastructure become very complicated. Okay. And motorcycle. So this slide, I made this 10 years before, and I believe that there's still room for motorcycle in the city. still the very important transport mode in the cities. Okay. And in the Western countries or Western countries, there are very few motorcycles on the street. But in this area, we need to continue on using this kind of very comfortable but dangerous transport mode. What we can do in the future. Okay. And Singapore, this is a quite unique country. So their government is very strong. Yes, and for these 50 years or 40 years, they could have a very strong transport policy to control the vehicle use and ownership. Okay. So in this area, so we have a lot of good and bad examples. Okay. Okay. Then those information was included in this book chapters. Okay. And my motivation is we need to consider the better transport systems for Asia. Okay. For Asia. So this is maybe, I believe, different from the transport system for European countries or United States. And most powerful, important, but challenging movement happened in this transport planning and management field in these 5 years. Okay. Have you ever heard this word, mobility as a service? Okay. Which was initiated by the Finland, European countries. Okay. And they developed one very big company or organization, the Mars Global, to initiate the Mars all over the world. Okay. And their definition of Mars, so it combines transport options from different providers. Okay. Sometimes we combine the transport services provided by the car industry and railway industry, okay, and IT industry, okay, and handling everything from the travel planning to payment. So recently, through the applications, they don't have to pay the fare directly to the drivers or operators. Okay. So payment automatically happen in application, okay, using the credit card or others. Okay. Until now, we should pay the fare, the provider by provider, okay, separately. Okay. And why Mars is important is this can realize the carless city or carless world. Because many of the people in the city may give up using car or having a car. Okay. to use the share mobility. Okay. Then now not only Finland, but for the every country try to have some initiative or some advantages in this new rising field, Mars. Okay. Then if I have a lecture 3 years later or 5 years later, my talk might be quite different from the current situation. Okay. I believe. Okay. And this may change radically our business in the transport and mobility. Okay. So you had better follow carefully the change in this field. And if I have time and enough knowledge, I will talk in deep in the last. Okay, this what is Mars and what will happen. Okay. Okay. Skip this. I already explained. So we have 3 elements in the transport system. Okay, way, vehicle, and terminal. And the role of ITS or ICT or IoT may provide the better connection among those 3 players. Okay, control. あ、これ出るかな? Control. 違うか. Okay, control. Okay, and of course, as someone said before, we have user, human being in this system. Okay, human being. Okay, a pen. This. Oh. なんか押すのかな? お、違う。Okay. So anyway, we have user, human being. Okay. Then this combination should contribute ourselves for better use of the transport system. Okay. Of course, this is a very conventional problem in the transport planning and management and still active. Okay. So we should always make a balance between demand and supply. Okay. Demand and supply. Okay. And historically, maybe just for example after the war, so our transport infrastructure was very bad. And anyway, we should increase the capacity of the transport network, okay, road and railway and others. Okay. But once we develop, we increase the capacity, the demand always more than the increase of capacity. Okay. This kind of aspect, not only India, but for Japan, United States, European countries, every country may experience. Okay. Then our challenges is shifting from the developing the infrastructure to manage the demand. Okay. Provide the minimum level of infrastructure and to control the demand, to avoid the imbalance between the demand and supply. Because imbalance between demand and supply always result in the heavy congestion problem. Okay. Okay. Then, okay, 2 more slides in my basic understanding in this field. Okay. So what is transport planning and management? Okay. At least in the planning, we should have a goal. Okay, goal to be achieved. Okay. To achieve the goal, we have measures. Okay, measures. And transport planning always for the 5 years or 10 years. Okay. Mid-term or long-term. Okay. So to achieve the final goal, we always monitor the situation. Okay. Monitor the situation. Okay. The planning is just a beginning. Okay. We just make a plan for 5 years, 10 years, and during these 5 years or 10 years, we should monitor, manage whether our plan is well or bad. If something happens, something wrong, we should change the plan. And what is objective or goal? Okay, we always consider the safety. Transport system should be safe. Please imagine if you use a transport system and you are said that this probability is 100. Okay, 1%. You may die. Nobody use. Okay. So safety is always a concern. Okay, concern. Okay, but sometimes to seek the very high safety conditions, it provides more cost for the providers. So we always consider the balance between safety and economy. Okay, cost. Or, of course, time saving is one of the very important factors for the transport systems. I believe you are the student, and the student mostly doesn't have much money. So students want cheaper transport means rather than the fast transport means. But if you got salary, situation might be quite different. Them, I think, very rich. So they can easily use taxi or expensive transport mode to save the time. Okay. Anyway, the time saving and its relation to the cost fare might be the quite important factors to design the transport system. Okay. And we have three kind of measures. Okay. One is introducing the new technology, okay, to change the services. Okay. And second one is we sometimes change operational conditions or operational technologies, okay, to make the system more efficient. Okay. And third one is we sometimes impose the regulations. Oppositely, sometimes deregulate, okay, to facilitate something. Okay. Or sometimes government have some initiatives like some subsidy to change the world. My understanding, the measures can be classified into three different aspects. Okay. Engineering, business, and economy. Okay. So, of course, one of the important role of ITS is to make this diagrams effective. Okay, so this is the last of the introductory part. So I'm not sure this kind of discussion may continuing on after finalizing the Mars world. But currently, urban form is quite or highly related to the transport portfolio. What kind of transport means we introduce? Okay. If there is no railways, only cars, what happens? Our urban area become very big and big. No control. Okay. If we can successfully introduced the mass rapid transit in the cities, our urban size can be minimized. Okay. The capacity quite different. Okay. Mass rapid transit have a very high capacity, okay, transport capacity. That car, it can only 1 to 4 people in the car. The train, sometimes, in the case of Tokyo, we can carry 3,000 people in the one train set in the peak. And we have 20 trains, 1 hour. Tokyo City, so we can carry so many people. So our case, 1 railway equal to the 20 expressways in terms of the capacity. Okay. So without railway, we cannot sustain our city because Tokyo is the largest, has the largest population in the world. Only the road we cannot sustain this. Anyway, we always consider the better relation between transport and urban form. Okay. To make our urban areas sustainable, we should well plan what kind of transport mode we should introduce. Okay. Okay. So this is conventionally used to understand what kind of transport mean or transport mode had advantages, okay, in the city. Operational meaning. Okay. For example, railway. To develop the railway system, it costs too huge. Okay. It costs too huge. This time, 2 days before, I saw some railway development areas near airport. Yes, Kolkata. I'm not sure how much, but I believe so expensive, so costly. Okay. This means we need to attract more passengers to make this project effective, okay, economically effective. We need to attract more passengers. This means population density along the railway should be high. Okay. This means we should ask city planners to set high population density area alongside the railways. Okay. Otherwise, railway business cannot be sustained. Okay. But car, okay, this is very powerful transport mode in the world. They can cover any kind of trip length. But normal passengers cars, they can carry at most 4 people at once. Okay, at once. Then, even though car can cover the various kind of trip lengths from the short and long distance, their capacity is very low. Okay, and the population density become lower. Okay, or the area with a low population density, the only car can sustain in that environment. And bus cover the intermediate situation, okay, intermediate areas of the rail and car. And the base compact city like European cities, sometimes in the city there are a lot of trams, okay, with some trip length is very short, but passenger length is very high. But in the case trip length is shorter, so railway is not always the better solution because it costs too huge. Okay. So this means if the urban area become very big, maybe for example distance with some 30 to 40 kilometers, in this case, every city should develop railway. Otherwise, they cannot sustain. Okay. Okay. And this is one of the evidence. Okay. One of the evidence. Okay. The horizontal axis is urban population density, and vertical axis is energy consumption. Okay. Mostly the use of car. Okay. Mostly use of car equal to use of car. Okay. And our cities, okay, have so high urban population density. Okay. And in this case, they may use the public transport services rather than having a car. Okay. Then energy consumption of car are minimized. Okay. But American cities, as you know, they develop so big areas. Okay. No apartment, and they develop a flat house using the large lot. Okay. And the population density become very low, and they should any kind of public transport services, including bus, cannot be sustained, and the residents should only use a car. Okay. Okay. And this is because the cities consume a lot of energy. Okay. Okay. And okay, this map showed the land use. Okay, land use of the Tokyo metropolitan region. Okay, and the black line shows the railway network. Okay, so along the railway, so you can find that dotted by red or pink. Okay, this means densely urban or commercial, residential or commercial areas. And so in the case, our case, before starting the motorizations, we can develop our city. Okay, and many of them have been using the commuter railways from the rural to Tokyo city center to work. Okay, we continue on this more than 100 years. Okay, before the motorization. So this is why Tokyo can accept around 40 million people in these areas. This is the largest in the world. Without those railway networks, we could not realize, okay, to accept so much population. But some areas without railways become pink and red. This is, of course, the effect of the motorization. Motorization. Okay. But anyway, Tokyo Tokyo was very lucky. Okay. Very lucky. Okay. I think no other cities except Seoul. So Seoul also has many commuter railways and urban subways, and their population density is larger than the Tokyo one. Okay. And they also have more than 20 million people in the city areas. Okay. Other cities in Asia, they have a lot much population, but they cannot still developing the railways. The situation might be quite different. Okay. And to save the time, skip those. Okay. どれがいいかな? Okay, これか. Then, do you know the word modal split? Okay, modal split. Okay, share of the transport mean in cities. Okay, and our case, 30% of the trip has been covered by the railway. Maybe this is one of the largest in the city, in the world. So car only 29%. This is less than the railway's share. This is very unique in the world. Okay. So before the era of Mars, the Tokyo had already succeeded in terms of the car-free cities. Okay. Car-free cities. Okay. But of course, rural side situation is quite different. They should use a car. Okay. But in Tokyo city center, more than half, almost half of the trip has been made by the railways. Okay. And mobility of the elderly people become more and more facilitated in these 20 years in our case. So current elderly people with more than 75 years old may go out easier than those in the 10 years before or 20 years before. So elderly people become active. Okay. Of course, one of the reasons is for some social change, but important reason is because we can provide the better mobility for them, ask them to go out. Okay. So red curve is the latest one. Okay. And the number of trips increasing. Okay. Last year we have the next surveys, year 2018. Now that we are calculating the result, I'm wondering the result. Okay. The elderly people, the more and more go out or not. Okay. In the latest 10 years. Okay. And okay, this graph is very important, okay, to understand the relationship between the population density and transport mode, use of transport mode. Okay. Okay. Let's show the share of the car use. Okay. No, opposite. Blue is share of car use, okay, and pink one is share of the public transport usage, okay. And in every zone, red plus blue become 100, okay, okay. Then symmetry with this line, 50%, okay. And if population density increased, car share become very low. But population density is very low, the people should use car. And in our case, population density of 30 persons per hectare, so this is 3,000 people per square kilometers, situation might be changed. So lessons our case. So to facilitate the public transport use, we should ask the transport planner, city planner, to secure the high population density, like for example, 30 persons per hectare. Ask them to develop the big apartment okay, to keep the high population density. Okay. Okay, so next issue is not in Tokyo, but for the whole Japan, what we did, okay, in this field. Okay. And this lecture is ITS application. So my talk mostly focus on some load, okay, field. No time to speak about the railways issues or other transport mode issues. So this time we mostly focus on the load. Okay. And I just summarize the very important policies happened after the war. Okay, after the war. So first we made act, okay, law for road development. This is around 6 years before. And we currently still follow this act. Okay, everything connects to this act, basic act for the road development and management. Okay, and after the war, we don't have much fun. we didn't have much fun to develop the road, so we should consider some special account to provide the funding. Special account, and we impose tax for the car ownership and petrol, this kind. Okay, so we secure the much amount of the funding for the road development. Okay, we start this 6 years before and end in 10 years before. So currently, this special account is absorbed in the main account. Okay, yes, quite strange situation happened. Okay. Okay. And until year 2002, we have totally 12 5 years road development plan to invest more and more. And our case, we have expressway system, okay, with toll, not free. Okay, and for developing the expressway network, we set up the public corporation. Okay, 6 years before. Okay, 6 years before, and to extend the expressway network all over Japan. Okay. And our case, road traffic, okay, infrastructure development is for the road administrator, but traffic control is for the police. Okay. Different. Okay. Okay. Then police agencies develop the Road Traffic Act. Okay. This is apart from the infrastructure development, but for the traffic management. Okay. Then, after 2003, we changed the conventional 5 years road development plan to the new plan. Okay. And expressway management was done by the public corporations, okay? But we changed this system around 10 years before, so ask them to be privatized. Privatized. Okay. And anyway, in total, we start from the intensive network development. But maybe from this century, our motivation is to maintain or manage the traffic or facilities, okay, rather than developing a new infrastructure. Okay. I think in your case, you would still have some intensive infrastructure development. Maybe I believe this may end in next 2 decades or 3 decades. And after that, you should care about how to manage the facilities. Okay. Because for the using 30 years, 40 years, infrastructure become deteriorated. And you should invest to make those facilities using more and more, okay, rather than making a new one. Okay, and trend of the transport planning. Okay, our case. Okay, again, after the war, our infrastructure was so limited, and we should invest more and more. Okay. But we realized that even though we add the infrastructure, demand become more and more, and we always suffering from congestion. And 30 years before, our mind is have some bilateral development plus management. Okay. And TSM, traffic system management, or transport system management, was the buzzword at that time. TSM. I believe this is the start of ITS. Okay, start of ITS. For example, developing the traffic control center to avoid the traffic congestion, to increase the capacity with some information or management actions by the data. We set up many sensors on the network and to monitor the situation and find some congestions or traffic accident automatically and having some actions to cope with those kind of problems. This is some start of the ITS, I believe. Okay. But demand is still ongoing, increasing, and this could not be effective. Okay. Finally, we ask the users to change their behavior. Change the time. Okay. Please avoid using the peak time. Ask drivers to change. Frankly speaking, very rare people can change their time or behavior, but if some, for example, 5% of drivers can change the time, traffic congestion might be radically mitigated. Okay. So our task is to find the 5% of the people, users. Okay. TDM, travel demand management. I think today. Yes, second days. Okay, you should learn about the TDM. Okay, TDM. And MM, mobility management, is a kind of TDM. Okay, mobility management. Ask the users to change intensively their behavior. Okay, using some psychological theories that provide the information intensively to the users, and sometimes they notice, I should change I should change my behavior. I always choose automatically the car, but sometimes I should take a bus or public transport. This kind. Okay, this is a kind of mobility management. And in the end of 1990s, the ICT environment has been dramatically changed. Okay. And this is a kind of second stage of ITS. Okay, first stage is just the traffic control center. And second stage, that we can develop the devices on board. And through these devices, we can do many things. Okay. And maybe around year 2000 might be the start of the second stage of ITS in case of Japan. And this ITS currently become maybe Mars in year 2020. Okay. Mars. Okay. But as I explained, so our infrastructure facility become damaged because 40 years and 50 years already have passed, and we should renovate and maintain. Okay. So kind of development. So go back to the 50 years before. Of course, we still have any kind of effort on the TDM and ITS. But as well, we should consider simultaneously the innovation or maintenance. Okay, this is a very broadly history of our road policies in Japan. And if we look US or European countries, the situation might be almost same. Korea, almost same, I think. But if we look this in India or other Asian countries, so maybe 20 years difference, but become faster. For example, the Mars will be implemented also in India in these 5 years, even though your infrastructure is not so good. So the case, this case is automatically cannot be automatically applied in your case, but basic structure might be almost same. The time is different, more short time, shorter time. Okay, have a rest. Okay, take a rest.
10 minutes break.
Okay.
Okay, so we have some refreshments outside. We will come back exactly in 10 minutes because we have to keep time. So please have some refreshments, tea, coffee. You want to use the restrooms, please do so. And it is 11.
So try to complete these morning sessions until 12. Okay. Okay. So still continuing on what we did. Okay. And so for transport planning and management, we should care about the history of the city development, for example. In case of Tokyo, Tokyo was started its history in around 500 years before. And at that time, the not the emperor, but some kind of head of army, okay, was developed, the capital at Tokyo in the beginning of beginning of 17th century. Okay, 17th century. Okay. And within 100 years or 200 years, Tokyo, ancient name Edo, was the largest capital in the world, with its population is more than 1 million. Okay. At that time, I heard there's no other cities with the population more than 1 million people. Okay. And at that time, land was completely separated by the class of the citizen. Okay. The top class have a resident apart from the sea, okay, to secure the good land condition. And their land lot become very big because they are very rich. Okay. And the lower class, commercial people, was the lowest category at that time, and they should live the very bad condition with very low land lot, small land lot. Okay. And currently, for example, Ginza, this is a very famous town in Tokyo, the commercial center, was, so ここで出せんだな。Sorry. It's this area. Okay. Ginza. Okay. That was formerly the land for the lower class. Okay. And if we compare this area and this area, the size of the land lot or shape are quite different. Okay, so if you check the map of current Tokyo, the street shape are quite different in the west side of Tokyo and the east side of Tokyo. This is because our ancient era, so we had such kind of road structures. So this is because we currently have some very big effect. Okay. Okay. And we have a lot of development plans to make our cities modern at that time. Maybe around 150 years before. At that time, we opened the countries. At that time, we never allowed to enter any foreign people except Netherlands and China. But after that, we finally decided to open our countries, and after that, we applied the latest advanced ideas coming from the Western countries to make our city modern. Okay. Then, firstly, we accept the horse and car, for example, horse and car. Okay. This need the wider street. Okay. Wider street. This time, the government set up the complicated road network to avoid the attack. Okay. Attack. But for modern cities, we should change the road structure, make the streets straight with wider width. Okay. Then we started this kind of radical change in the street form, and 150 years before, and we still struggling with this kind of change. Okay, and sometimes, for example, today, March 11 is a very good, important day for Japan because 8 years before we have so big earthquake and tsunami happened just today. Okay. And in Tokyo, we had so big earthquake damage in 1923, okay, just more than 100 years. At that time, most of the Tokyo city area was burned out, mostly in the east side. And at that time, we changed the land shape. And this kind of effort, owing to this kind of effort, east side of Tokyo had a very good street structures, okay, compared with the east side, west side. Compared with the west side, the road is not straight and be narrow. But east side, we can have some dramatic changes in terms of the shape and structure. Okay. And second damage was the war. Okay. In the year 1945, the Tokyo was burnt out by the attack by the U.S. Okay. And maybe this is, March 10. March 10, yesterday. Okay, yesterday. Okay. We had a bad event in March. So, yes, and at that time, second chance to change the urban structures, including the road networks. But at that time, our financial situation was very bad, and it could not complete. We have a big plan, but due to the lack of financial resources, we cannot complete. And we are still struggling with the problem caused by this incomplete planning. I will talk later. Okay. At that time, for example, we'd like to introduce the very wide street, okay, wide street with 80 meters or 100 meters, very wide one. There are many sites in the Tokyo city center, but incomplete. Okay. And the modern city development plan, including the street planning, was initiated in just after the war. And some of the plans are still ongoing. ongoing, not completed yet. Because after the war, economy has been dramatically improved, owing to the war happened in the Korea 5 years later, and many people come back to Tokyo and resident. And before setting up those kind of new formations, we should accept so many populations. And they neglect the plan and to start living on the planning site. So almost no control after that. Okay. So we are still suffering from this kind of problem. Okay. And road development plan in the whole Japan. This is quite interesting to observe. For example, so this is the first expressway plan in Japan. At that time, we called it national trunk highways, but this is almost equal to the expressway currently. Okay. just before the war, okay, 1943, during the war, okay, during the war, 1943, okay. And currently, for example, Tokyo, Nagoya, Osaka, and Fukuoka, this area, the center of the national economy, okay, in Japan. Maybe population might be 70% or 80% of the Japanese live this corridor, okay, currently. Okay. But this area, Japan seaside, currently, in terms of the economy, not so important. But at that time, due to the military reason, because China, Russia, so compared with this Pacific areas, so Japan Sea area was very important. Okay. The reason of the road planning or development is apart from the economic reasons at that time, political or military reasons. Okay. For example, no plan. A very pessimistic situation. No plan in this island, and south of island, no plan. But this, because this is here, there's Sakhalin Island, Russia. Okay. At that time, that land was formally this was Japan. And we convert this and 4 island. Okay. But we still have some difficulty in settle down this kind of. So currently, this Wakkanai only have maybe 30,000 people. In terms of national planning, not so important. But we have a plan at that time. Okay. But after the war, the situation dramatically changed because no connecting expressive plan there. Okay. This compared with this. Okay. Then our most investment happened in this. We call this as a Pacific Ocean Belt. Pacific Ocean Belt. Pacific Ocean Belt. And finally, this island have a plan. Finally, and south of Kyushu, I was saying. But this plan, we set the corridor like this, and this kind of separation happened. Okay. And this is the largest plan happened in Japan. Okay. 1987. At that time, Japan was the strongest country in the world in terms of economy, in the bubble. Okay. We bought the many buildings in the US, and the US government finally get angry. Okay, then ask us to invest more in your country. Okay. So after accepting such kind of claim, we developed a plan to invest more. Okay. So this is because this is the largest, okay, largest 14,000 kilometers plan. This plan is still active. But considering the financial constraint, the ministry never said this is an active plan. But I believe this is still active. If they have a chance, they try to develop everything. And the difference is, again, we have this kind of link. Because due to this plan, associated with the economic plan, around 60 to 70% of population concentrate on this corridor. Okay. And the decision of the national government distribute more population more on the regional areas. And one of the key is to develop the expressway network. Okay. So this is because, again, we highlight the less populated area, okay, to connect the cities by expressway to facilitate their economic situation. Okay. At that time, Japan was rich, and maybe if we maintain the economy, we complete this within 20 years. But maybe 2 years or 3 years later, our economy going down, failed. Okay. Okay. And at that time, one of the very important decision is to accept more private funding to develop the national infrastructure. Okay. And this, okay, しとこうかな。邪魔。あ、ダメか。Noだな。Okay. Okay. So in this plan, okay. Okay. In this plan, so this new network, okay, was proposed. Okay. This expressway is the most congested expressway in Japan. Okay. And to minimize the delay, and this expressway link is very weak for the disaster. For example, this part, they cross the sea, and once tsunami happens, this network will be damaged. Okay. And same as this. Then, to secure the national security during the disasters, we decided to add one more expressway link, the safer place. This plan was developed in 1987, and still developing this. Still. Maybe next year, next year, this project will be completed. Now we are developing this final part. Final part. And at that time, Japan economy was strong, and our attention was mostly paid for the time saving rather than safety. Okay. So we decided to develop this link with a maximum design speed of 140 km/h. Very fast. Very fast. Japan mostly, many of the expressway link was designed with a design speed of 120 km/h, but in the implementation, we keep the 100 km of the speed limit. Okay. 140. And if we decided to develop the high-speed expressway, what happened? So we provide the radius become large. Okay. to minimize the force at the curve. And the gradient also same, 2%. Normally we designed 5%. Maximum 5% will be allowed in the normal expressive ring, but this ring, this should be 2%. Okay. And this area is in the mountain. Okay, mountain. So to keep this rule, we should dig long tunnel. Then between the tunnels, we should connect the very gorgeous bridges. Okay. Now, construction costs become very expensive, 3 times than the usual expressway. Okay. But at that time, Japan economy was very excellent. Then we can do this kind of, we could propose this kind of planning. But start planning or start developing, economy became very worse. But we try to continue on this project. And it takes around more than 20 years. We almost finalize the project. But the current economic situation are quite different from that in the 1987 during the bubble economy. So for developing a transport infrastructure, we should consider this kind. We should have some long-term viewpoint. So this is the very bad news, but I believe this kind of information should be more and more explained to the other countries to ask them escape of this kind of error. Okay. Okay. And associated with this plan, so we develop the sea tunnels and the bridges connecting. Okay. With 15-kilometer ring under the bay, okay, on the bay, okay, at Tokyo areas, and for 15-kilometer ring, so huge project cost. This is maybe around 20 times than the usual expressway ring. Okay, this also planned in the associated with this, and start construction during the just end of the bubble economy, and finally operation started 1997. In 1998, do you know what happened in the 1997 or 1998 in terms of economy? Have you ever heard? So many countries facing some crisis in economy and finance. なんていうんだっけね、通貨危機、crisis of monetary crisis, okay. Monetary crisis. Okay, like Korea, they are suffering from this kind of crisis and affected by Korea, so we also have the same problem. Okay, the timing of the opening of this is so bad, so bad. Okay, and this project we should cover this cost by the toll. User should pay. Okay. And we set very expensive, for example, almost $40. Okay, $40 only for the 15-kilometer network. Very expensive. But during the bubble economy, we understood this project can be successful, even though we ask the users to pay this so expensive toll. Very strange. Okay, and to 64,000 daily traffic under this fare is how does it sound? In these conditions, we can cover all of the cost of the project. But what happened when we open this? So we, of course, max toll was reduced from 4,000 to 3,000. Okay, and this is maybe 25% of the projected traffic volume, even in the fare reduction case. At that time, we had so severe criticism. What transport planner did? What happened? Okay. This is a kind of big failure in our field. Okay. I've never been involved in this project. Of course, I was young at that time. But my supervisor at that time was strongly involved in this project. Okay. And at that time, due to some political request, fare became 1,000. No way to keep the cost, all of the cost, covered all of the cost. Okay, but due to the many discount policies, demand itself become increased. Okay. Recently, we are very severe. We are suffering from the problem of the very severe traffic congestion currently. I think this should be yes, more maybe back to 1,000 or 1,500 kind to manage the congestion. Okay. This is kind of some difficulty in the planning in the long term. In the second case, first case, second case. Okay. And this because this expressway system is very important for the ITS. Because one of the key elements of the ITS is electronic toll collection. Okay. I will explain maybe Wednesday. I will explain Wednesday, I think. But ETC development is associated with this expressway planning and management. Okay. And after the economic crisis and there are big criticism in this field, there are many politicians ask us to give up developing a new expressway. Okay. Because for example, this corridor very profitable. Okay. Profitable. Because we already completed all of the project, just operation. Almost no cost except management cost. And so due the owning to those high traffic volume, we can enjoy the high revenues, okay, from this link. But currently we develop, for example, this or this or this or for example, this. We cannot enjoy the high revenue, high profit. So at that time, the expressway network was operated and developed by the public corporations. And the revenue of this load link has been transferred to develop the rural side. Okay. So one of the very important principle in this field is a beneficiary pay principle. So those who have a benefit should pay the service. Okay. But the users of this link, the part of their toll for the service can be converted to this area, and many of them never use this link. Then there are very big criticism on this system. Okay. Then our final decision is to give up this kind of public cooperation system and make network divided into 6 different zones and set up the new company style management body, okay, by giving up the public cooperation at once. Okay. And before this system, year 2000, we start this, 2005. Okay. We start this. So before that, a public corporation develop the facility and own the facility and operate. But from 2005, government had the facility. Okay. And those operating company borrow the facility and operate. Okay. And but for example, those companies develop the additional network, can develop the additional network, but that facility is this facility owned by the government. So anyway, so have we ever heard the word vertical separation? Vertical separation. Vertical, infrastructure and management. We divide. Different management body. The infrastructure company manages the infrastructure, okay, and the operating company manages the operation. Sometimes those bodies have some close relationship, but sometimes no relation in finance. So our case, we introduced this vertical separation system. Okay, in the year 2005. And through this policies, that management become a little bit efficient. Because in the case this company tried to develop the unprofitable route, this decision might be very difficult. Okay. The problem of the expressway link is we still have this kind of problems. Okay. Typically observed every weekend or holiday season. Okay. So this picture may be around どのぐらいかな? この辺りかな? This. Okay. So we have maybe I will explain later. So we have 3 rings, okay, and 9 radial networks from the Tokyo city center to the suburban, okay, and Okay, this is most congested. Okay. Expressway connecting Tokyo, Nagoya, and Osaka. Okay. 3 major cities in Japan. Okay. And this is the additional expressway again connecting between Tokyo and Nagoya. Okay. And this area is very famous for the tourism. Okay. And every weekend on Saturday morning, the people in Tokyo have some travel to those tourism site destinations using this expressway link. And some of them stay there, and in the evening of Sunday, they will come back. So in the morning of Saturday, there are very severe congestions outbound. Okay. And in the evening of Sunday, so we have so severe congestions inbound, okay, to the city. And situation like this. If we have enough technology to shift, move. So in this situation, we add the one more lane to this direction, こっちかな, to increase the capacity. Okay. Because very few cars on this with 4 lanes. But of course, this is very difficult. Okay. Difficult. Then recently, so TDM, demand management, was very hot issues to cope with this kind of severe problems. Because this congestion happened by 5% or 10% of excessive demand. If we ask the 5% or 10% of driver to change the time, theoretically no congestion happens. Okay, most important point is that most of the travelers want to go back to home earlier because on Monday they should work. Okay. But if someone kindly stay more time on the tourism destinations, maybe 5% or 10%, they can enjoy the more time in tourism destinations, and maybe travel time to the home might be minimized. Then my idea is to change the toll. Okay. Because most of the drivers already have a ETC unit. Maybe more than 90% drivers have the ETC in Japan. So we impose the highest toll to the non-ETC users. Then ETC users who can change the time, there might be some discount or refund. Very, very easy to do this. Okay. So congestion pricing or congestion toll based on some ITS technology might be quite important to cope with this kind of problem. But our case, setting the toll is so political. Maybe same in your country. So political. Sometimes very we have some much difficulty in this kind. kind. Okay, and this urban expressive link, regarding the plan, we already have this kind of plan with 3 rings, those ring road, around 80 years before. Okay. And the uniqueness of the Tokyo's road network is because we have this urban expressive network. Okay. I believe this is quite unique in the world. For example, in the European cities, they don't have expressway or highways in the city. Every expressway or highway end in the suburban of cities. And United States, they have interstate highway system, and actually they have interstate highway link inside the city, but not well networked. Okay. Our case, in Tokyo city center area, maybe with 600 kilometer per square meter, 600 square kilometer, its area was. Inside this, we have more than 300 kilometers expressway link in the urban city center. Okay. And this traffic covers more than 1 million vehicles. I'm not sure how many vehicles in the Tokyo city center daily, but maybe I think this covers more than 10% of the total demand in this region, I believe. Okay. And we started to construct this more than 50 years before, just before the first Tokyo Olympic Games. Okay. And this have, sorry, very difficult to see. So this is ring and this kind of network. Okay. This second ring was operated by a different company. Okay, different company. Okay. Okay. And so recently we are facing the deteriorated infrastructure because first section was opened more than 50 years before, and we have a so big renovation plan now we have. This means once we close some sections and to renovate, sometimes we change the bridge structure. So to complete this, we are suffering from so severe traffic congestion situations. And we hope the toll setting through the ETC might be the powerful key, a powerful tool to manage this kind of traffic congestion. But this is a kind of some very important role of the ITS. Okay. Oh, 12. Okay. So maybe in the afternoon sessions, I will continue on this. And hopefully, I will enter into some data collection technology issues, which will be talked tomorrow. Okay. Okay.
So we'll finish our first morning session now. You all kindly make sure that you, I think the student volunteers can help you go back to your hostel wherever you can have food, or there are other places here to have food. so you can have food anywhere. But please try to come back by 1:45.